Hello students, myself Dr. Rupali V. Goel, Assistant Professor in Civil Engineering Department SVIT Vasar. Today I am going to discuss about the topic of cofferdam, which is included in the syllabus of GTU for Civil Engineering in 6th semester, subject of Advanced Construction and Equipment, that is having code 2160601, as well as per new syllabus of 3rd semester, it is included in the subject of BCT, that is Building Construction Technology, having subject code 3130607. So when we are talking about this cofferdam, these are the contents that I am going to discuss with you. So here, definition. First, you should know what is the meaning of cofferdam, its uses, requirement of cofferdam, selection criteria of cofferdam, types of cofferdams, its design features. Then leakage is the major problem in cofferdam. So about that we will discuss. Then economic height, and the last point. So here first we will understand what is the meaning of cofferdam. So for this, the meaning of cofferdam is from the word coffer. The meaning is box. So here also we have to construct similar kind of box. So here in this figure you can say it is a box kind of structure which is constructed, and it is useful to take up the foundation work in a marine region. So whenever there is a flow of water which is coming and you want to do your work in a dry condition, and then we have to obstruct water flow. So to obstruct this water flow, we have to construct some box type of structure which is generally called as cofferdam. So it permits the dewatering and construction of the permanent facility. So any structure which is to be constructed underwater in dry condition, we have to construct cofferdam. So if you want to define it, it is a temporary structure designed to keep water and or in certain cases soil away from the excavation in which bridge, pier or other structures are to be built. So here you can see that all the structures that are generally box kind of structure which are constructed to keep water away, or in certain cases soil away from the construction site, or you want to do your construction. So what are the uses of cofferdam? So there are many uses of cofferdam. So here the list of all these options are given. So first, to retain the soil and water, this is the first important use. Next is to enclose the space for the removal of sunken vessels. So certain time some vessels अगर नदी में या फिर ocean में वो sunk हो गए, तो if you want to take out, then in that case you have to construct the box all around that, and you have to dewater and you can take out them. To provide the working platform for the foundations of building when water is met with. तो जहाँ पे भी पानी आ रहा है फाउंडेशन में, सो इफ़ यू वांट टू अवॉइड, यू हैव टू गो फॉर द कॉफरडैम. टू प्रोवाइड द स्पेस फॉर कैरिंग आउट द फाउंडेशन वर्क विदाउट डिस्टर्बिंग और डैमेजिंग द एडजॉइनिंग स्ट्रक्चर. एडजॉइनिंग स्ट्रक्चर पे आपका मशीन वाइब्रेशंस ट्रांसफर ना हो. फॉर दैट पर्पज ऑल्सो यू कैन कंस्ट्रक्ट बॉक्स काइंड ऑफ स्ट्रक्चर. So main purpose is to provide the dry working area for the workers, and it is constructed to facilitate the pile driving operation also. So generally underwater construction जहाँ पे pile driving हम use कर रहे हैं for the bridges etc. Then to keep water away during this pile driving operations, we have to go for cofferdam. It is also used to place the grillage as well as raft foundations. It is used when the foundations for the piers and abutments for the bridges which are used. So basically piers are the internal pillars which are provided in bridge, and the end supports of the bridge, it is generally called as abutments, and sometimes it is also used to provide now. So in all sectors we can utilize this cofferdam, right from the general construction work of underground car parking, basement etc. In all the transportation engineering work, bridge, pier, support wall, then in water engineering for construction of weir, culvert, scour protection walls etc. In the port construction, docks, harbors, jetty etc. we can utilize cofferdam. So there are certain requirements of cofferdam that is to be fulfilled before you choose any type of cofferdam. So first requirement is it should be reasonably watertight. Actually absolute tightness is not required, because it is a temporary structure. So if you are providing absolute water tightness, then it will become expensive. So generally reasonably watertight structure is required. Normally it can be constructed at site, and total construction, maintenance and pumping should be minimum. So we have to construct in such a way that this cost should be minimized. It should be designed for generally maximum water level and other destructive forces, because generally it is underwater construction. It should be stable against bursting, overturning, sliding under the floods and waves, because if it is destructed, then our whole construction work would be hampered. The water to be excluded, it may be groundwater in certain cases, or it may be surface water, so that condition you have to look after. Then it may be still or running, it may be deep or shallow. So these are all the conditions that you have to properly think for. Then material used for the construction, it may be different materials can be utilized: timber, steel, earth, or concrete. And it types depends on the depth, soil conditions, fluctuations, and hardware available. So depending upon that, you can choose a particular type. It should be planned in such a way that the dismantling is easy, because as it is a temporary structure, it is to be reused somewhere. So dismantling should be easy. If the large area of the site is to be enclosed and the hard bed is available at reasonable depth, it is advantageous over caissons. Now these are the selection criteria for selection of different types of cofferdams. First is very important, that is area to be enclosed, so whether it is large or small. So generally for the large area it is advantageous over caissons. Depth of water to be dealt with, that is shallow or deep water, low head of water, then earthfill cofferdam are generally provided. The materials available at the site of the work, that will also decide the types of cofferdam. Possibility of overtopping by the floods, etc. Next is nature of bed on which the cofferdam is resting. So generally for the soft clay or heavy earth-filled crib or cellular cofferdam could not be utilized, but single wall sheet cofferdam you can utilize for this condition. So you will learn in detail about these different types of cofferdam. The nature of velocity of flow, whether this water is flowing with a slow current or with a swift current, it will also decide which kind of cofferdam is to be used. Chances of erosion of the bed due to reduction of the water way, because when we are constructing cofferdam, the waterways will be restricted, and that will restrict the water, and it will reduce the waterway, so it will increase the velocity. The facilities available for the transportation of the equipment and material is also equally important while selecting different types of cofferdam. Now here these are the different types of cofferdams. So just make the list of all the different types. In examination many times it is asked. So first one is dikes. Dikes is nothing but it is the embankment of some material, કોઈ પણ material નો ઢગલો, that is generally called as dikes. So this dikes may be earthen dikes, earth material નો ઢગલો કરીએ, so that is called earthfill cofferdam. So generally it is used for the low level, that is 1.2 to 1.5 meter maximum, and velocity of water, definitely earth use કરીએ છીએ તો વધારે velocity નો water we cannot utilize. Then rock filled or rock dikes. So here instead of earth fill we have to fill it with the rocks. So mainly certainly it is having more height as compared to first one, and that can be utilized for swift water. Third is sandbag dikes. So just a sandbag stack કરીને you can control flow of water. So generally it is used to divert the course of water. So this dikes is very important. Next is single wall cofferdam, then double wall cofferdams, then cellular cofferdams, timber crib or rock filled crib cofferdam, then concrete cofferdam, movable or suspended cofferdams. Now we will study each one, and that is first starting with the earth dikes or earthfill cofferdam. So here in this figure you can see just earthen material, that is having embankment of that, and here the walkway is provided at the top. So earthfill cofferdam is the simple type of cofferdam. Here in this figure you can say that it is consisting of the row of steel sheet pile. So here this is steel sheet pile, and here it is on both the side it is filled with earth fill. So generally materials used are mixture of clay and sand or gravel. So here this earth fill cofferdam, that's why earth filling of mixture of clay and sand or gravel is used, so which is generally called as puddle. So it is nothing but mixture of clay and sand. So generally as it is a earth fill material, the pores might be there. So riprap are what? So this is nothing but it is called as the riprap. They are small stones which are provided to protect against the wind and wave action, because if just it is simple earth fill, then it may be eroded in case of water high water flow, or in case of wind flow. So this riprap is provided to protect against that, and it is provided with certain slope. Here the slope is given, here the depth of water is given, here this walkway is provided at the top, here also small stones are provided, here drain is provided to collect the excess water. So this sheet pile, it should enter up to the impervious layer, and this type of cofferdam cannot be utilized where there are chances of overtopping of water, because if some overtopping of water would be there, then it will be washed away. આખો કોફરડેમ ધોવાઈ જાય. સો ઓવરટોપિંગ થવાના ચાન્સ હોય ત્યાં આ ટાઈપનો કોફરડેમ યુઝ ના કરી શકાય. સો વન્સ ઇટ ઇઝ ડન, dewatering of the water is done, and the whole area that is becoming dry, and that you can utilize for the construction. So it is suitable for the shallow depth, as I discussed, 1.2 to 1.5 meter. Low velocity, generally freeboards, means above water level 60 to 90 centimeter level is kept. Top width of the earth dike, it may be kept as 1 meter. Then suitable side slope, already I have discussed, provided with suitable drain. It depends upon the soil availability and site conditions. And for dry condition, clay embankments are generally provided, and for the wet condition, sand materials are generally used. And after completion, water from inside is pumped out, and foundation work is started for actual structure. Next is instead of earth filling material, it is completely filled by rocks. That's why it is called as rock dikes or rock filled cofferdam. So here in this section you can see this is steel sheet pile, and all it is surrounded by the rocks, and it will rest on the impervious layer. So here also drain is provided to take out excess water, and this is the water level outside. So it is similar construction as earth fill cofferdam. It can be constructed with the steeper slope as compared to first one, and it is economical where rocks are available cheaply. It may be utilized up to depth of 3 meter, and in case of high head of water, this can be achieved by clay or concrete core wall, and impervious layer provided in the form of sheet pile. So here this figure shows rockfill cofferdam with sheet pile. So in other cases, it may be provided with the concrete or clay core wall at the center, and it can withstand the overtopping of water without danger. So here both the rockfill cofferdams are shown. This is with the core wall, it may be of concrete, and here it is simple figure of rockfill cofferdam. Next is sandbag cofferdams. So it is very simple. The sandbags that are stacked, and they are used to restrict or to prevent the entry of water. So it is the sandbag cofferdam is the mixture of sand and clay which is filled in bag. So generally in the bags, sand and clay is filled, and such bags are placed at the place where you want to restrict the flow of water. So generally empty cement bags that are used to make it watertight, because it's a binding material, cement, and these bags can be partially filled, and the voids of the sandbag may not exceed 40%, because there would be larger voids that may be present between the sandbag. So suitable provision is to be done to minimize the amount of voids, and all the joints that can be filled with the help of puddle, and generally it is used for the small depth of water. Next important is type of cofferdam which is called single wall cofferdam. So here in this figure there is a single row of sheet pile that is provided all around the area to be enclosed. So this is the dry working area in which we have to work. So initially there was water, and by insertion of all the single sheet piles, single layer of sheet pile, it is enclosed, and then dewatering is done, and then after this work is done. So here the single wall cofferdam is used at places where the area to be enclosed is very small, because inside you have to work, and single row of sheet pile is used on either side of the cofferdam. And there are two types in this. First is wooden sheet pile, which are used for the water depth up to 10 meter, while if you are using steel sheet pile, it can be used for the depth up to 25 meter. So generally for the construction, soft material which are lying At the bed level of the river, it is to be first cleaned. Then guide piles are to be driven deep in the river bed at a distance of 3 meter. Then so first guide pile at 3 meter distance. Then a single row of sheet pile is to be provided on a whole length of the cofferdam, and inside of the cofferdam is strengthened by wells and struts. And once the construction is done, water is pumped out, and then inside can be utilized for uh, uh, construction work. And generally the sandbags, they are stacked on the inside and outside faces of the sheet to increase the stability of cofferdam. So here in this figure, it's simple sheet piles, layer of sheet piles. Now these are called as wells or wellings, and that are strengthened by these struts. So here in this figure, if in exam it is coming, you can draw this kind of figure, that is plan of single wall cofferdam. So I will explain the whole procedure in this section which is taken at AB. So first is guide pile. So these are the guide piles. Here you can see this is guide pile. So in plan you can see. So this first guide pile is to be inserted. Then after you have to insert these wells which are perpendicular to it. Then after, a single row of sheet pile is to be inserted. So this is sheet pile. Again it is strengthened by wells, and then after these horizontal struts that are provided. So generally this section, it is of 10 meter by 6 meter. So here this section of single wall cofferdam, it is shown, and inside whatever water is there, that is to be pumped down, and this area that can be utilized for working under dry condition. So which various points are to be considered for single wall cofferdam. So first, sheet pile should be vertical sheet pile होना चाहिए. In case of steel piles, put grease in the interlocking clutches to prevent the rusting, and it is also easy to remove. Then earthen banks can be provided outside the dam to avoid the water. So earthen bank outside पे provide कर सकते हैं. And corners should be constructed with special fabricated sheets. So corners are very important to avoid the leakage. Then inside should be supported by braces, struts and earthen banks as per requirement. So already I have told you that guide pile, then wells, then sheet pile, then again wells and struts. Then shape of the cofferdam, it may be depending upon the nature of work and area to be enclosed. It's not like always it is a rectangle, it may take any shape. So these are some of the actual pictures. So here you can see single layer of sheet piles. These are struts. So here also you can clearly see in this figure, this is the sheet pile. Sheet pile is nothing but you have learned in your pile foundation, it is non-load bearing pile which is vertically driven in the soil or in riverbed level, and these are wells, and these are struts, wells and sheet pile. So next is double wall cofferdam. So it is also with the help of sheet piles only. So here you can see these are the sheet piles, but here instead of only one layer of single sheet pile, here there are two sets of sheet piles are used, and inside this some filling material are to be provided, and the whole double layer that will be surrounding your area. And then after this area where you want to work, that is to be considered as dry working area after pumping of water. So here also you can see similar kind of arrangement, sheet piles are there, but that is two layers of sheet piles, and that is to be filled with certain material to so it is more stronger as compared to single wall cofferdam. So here in double wall cofferdam, when the area to be enclosed is large, it is necessary to provide the double wall. And here there are two types. First is Ohio River wood sheeting type of cofferdam, and second is timber or steel sheeting cofferdam. So this Ohio River wood sheeting cofferdam, the name is given because it was frequently used in the Ohio River in USA, and it was also cheap and built up rapidly, and suitable for the hard bed where there is no problem of erosion. हार्डवेयर अवेलेबल है, इरोजन का चांसेस कम है, वेयर यू कैन यूटिलाइज इट. Then it can be also used for the soft bottom, but if it is to be protected against erosion and not suitable for the deep water or water with the swift current. So these are the two conditions under which it is not advisable to use double wall position. So here you can see when it is inserting, this will be in a diagonal position. So after several sections are placed, separate gang of workers will come and they will operate from the second barge, and they will fix the sheet pile. So initially wells etc. is done, then sheet piles are to be fixed and nail them with the wells above water level. Then outside bombs are provided on both the sides. So bombs are nothing but it is the filling material with the earth or certain different material. So after work is over, the reverse process is done. So reverse process में पूरा काम करके that has to be dismantled, and then sheet piles can be reused for, but sometimes these wells they may be broken, so they cannot be utilized. So here the figure is shown for the double wall cofferdam. So initially these are the wells at around 1.5 meter which are fixed. Then here these double planks are there, 1 and 2, and then after it is consisting of the sheet pile. So this is sheet pile. So here two layers of sheet piles you can see, and these are called as these are tie rods. Tie rods initially they are very loose so that it can be inserted in water easily. Then after these are your strut portion, and these are called as cross presses. These are cross presses, this one. So these are earthen bombs which are provided on both the sides just to keep water away from the cofferdam. And inside this again you can fill certain material if it is required, and one side, so here this dry side that can be utilized for the construction work. Next is wood sheeting cofferdam. So it is useful for the depth of 6 to 10 meter. So generally wooden sheets are used, and that is used for the ordinary type, but for the large area and more depth, then you have to utilize steel sheet pile. The components are similar here: vertical guide piles, then horizontal wells and caps, then vertical sheet piles, then puddle filling, then tie rod to connect the guide piles and struts. So as far as the construction is concerned, soft materials that is to be removed, that is called as dredging process. Then guide piles are driven at the distance of 2 to 3 meter. Then horizontal wells are fixed between the guide piles. Then space is filled with the puddles, and bomb of clay, bomb that is outside bomb that can be provided on the outside to prevent the leakage. So here similar kind of construction work. So first guide pile, so this is guide pile is to be inserted. Then after this cap here it is shown, then wells are there. So here next insertion of your sheet pile, then here these horizontal struts are shown, then after in between the puddle is inserted. So generally if height is less than 3 meter, this width may be equal to height. If height is greater than 3 meter, then width may be equal to 3 plus 1/3 of h minus 3. That is generally kept for the wood sheeting cofferdam. So here also there are two sheet piles, row of sheet piles are used. That's why it is called as double wall. And if it is wood, then it is wood sheeting. If it is steel, then it is called as the steel sheeting cofferdam. So here you can clearly make out the difference between single wall and double wall cofferdam. So here single layer of sheet pile is there on outside your working area, while here in this case double sheet piles that are used, and inside that the puddle is utilized to make it more stronger, and then after it is utilized for the dewatering, and then after construction inserted. So ultimately it will take a shape like this, all the cells, and you can construct in very large area. So here once one cell is constructed, it will become platform for other to work further. So here this is a diaphragm cell. The shape is not circular, but it is diaphragm cell, and this radius is kept same. एज डिस्टेंस बिटवीन द क्रॉस वॉल, जितना डिस्टेंस क्रॉस वॉल के बीच में है उतना ही उसका रेडियस है. देन दिस इज सिंपल सर्कुलर सेल्स. So series of completed circles are joined together with the arc. So here between the two cells this kind of arcs are provided. Requires more material for filling but less steel requirement per running length of the cofferdam in this particular circular cells. So here cellular cofferdams with modified circular cells are shown. So here some different arrangements instead of arcs, this kind of cells are provided. And here this is cellular cofferdam with overlay shell. So different arrangements in terms of making these cells can be done, and that can be called as cellular cofferdam. Now the next type of cofferdam that we will discuss, that is called timber creep or rock-filled creep cofferdam. So it is generally consisting of timber creeps made from the log of woods and generally constructed on land, and then after it is floated at the places, and it is desirable to remove the loose material. So that is the general requirement for all of the cofferdam. It consists of unit of cell which is open at the bottom and having the framework of horizontal timber members. So here you can see all these timber creeps, and that are filled with the rock filling inside. And here at one side the sheet pile is provided, and this is your earth filling on the water side, and dewatering is done from this, and this dry working area is utilized for the purpose. So generally the hollow space which are formed here, that are filled with the rock between the timber creep, and the sheet pile already I have explained in the figure everything. So ideal conditions for such kind of cofferdam, if it is a swift current, danger of overtopping is there, depth of water is 10 to 20 meter, and limited working space is available. And so here this figure shows the making of timber creeps. So such kind of creeps are to be inserted at different height, and that is to be filled with the rocks inside. So this is one of the last squared timber raft to float down on the Ottawa River in 1900. So it is made up of more than 70 creeps. Next is concrete cofferdam. So they are nothing but small concrete dams. So these small dams, there are either precast or RCC, but as we are using RCC material, it is costly, and it can be incorporated as a part of permanent structure also. So they are generally used for following condition: when headroom limitations prevent the driving of sheet pile. So here you cannot find any sheet pile, directly you have to insert this. Then avoid the vibrations from pile driving, and ground contains boulders etc. Which may split the sheet piles. So boulders होते हैं तो it is very difficult to insert the sheet pile. So in that case such kind of ready-made concrete box can be utilized for as a cofferdam. So next is movable or suspended. As the name suggests, from one place to other place you can easily move it. So generally it is concrete type of concrete type of cofferdam can also work as the movable cofferdam. So it is the single unit to be reused several times, and where there are numbers of repetition work is required, such as the piers of multi-span bridges. बहुत सारे piers हैं multi-span bridge में. So for each single piers you can go for such kind of cofferdam. Then it is to be lifted first, then floated, and then placed at other position. So it results in economy. It can take any form, and generally hollow steel cylinder is also utilized, and a watertight timber box can also be utilized as a movable cofferdam. Now the most important thing to prevent the leakage in cofferdam, because it is reasonably watertight. So how to prevent this leakage in cofferdam? So first the leakage or the water may enter in the cofferdam from sheet pile, और second underflow, sheet pile के भी नीचे से पानी आना, that is called as underflow. So what are the measures can be done? Pumping of cement grout, जहाँ पे भी cracks दिखे cement grouting करो. So materials such as clay, sand, ashes etc. can be dumped all around the cofferdam. Then you can take a box which is filled with the mixture of sawdust, લાકડાનું વેર and ashes, that can be held near the joint along with the water, and it will flow through the joint and ultimately it will seal it. તો જે પણ લાકડાનો વેર એની સાથે જશે પાણીની સાથે તો જ્યાં જ્યાં ક્રેક હશે તેને ફિલ કરી દેશે. ઇન્ટરલોક્સ ઇન કેસ ઓફ ધ સ્ટીલ શીટ પાઇલ્સ it should be provided with enough quantity of grease, so that will also stick all the finer material and that will also avoid leakage. If serious leakage is observed, then canvas coated with tar is generally placed over the area of leakage. Now next is for double wall cofferdam, that is puddle for cofferdam. So what is puddle? That is mixture of clay and sand or clay and gravel, and the clay which is utilized, which is called as cohesive and impermeable. So generally we have to do the test for cohesiveness as well as impermeability. So to know the cohesiveness, a cylinder of 40 mm diameter and 250 mm length is prepared from the clay and water. It is suspended from one end while it is in wet condition. If does not break, then it is having sufficient cohesive property. And for impermeability, sufficient quantity of clay is mixed with the water to form a plastic mass, and water is stored above it. If water is held for some time, you can say it is having sufficient impermeability. So these two tests are generally done before selection of puddle. Next is design features of cofferdam. So generally it depends upon various factors such as hydrostatic head of water, so कितना head है पानी का, that is important. Dimensions of area, so large or small. Subsoil condition is very important. Fluctuations of outside water level, then possibilities of erosion, ice, floating logs if something is there, stem of cut down trees, etc. if it is coming. Pure theoretical knowledge is not in the design is not possible to prevent the failure of cofferdam. Some practical aspect are to be applied. So practical knowledge or experience with the theoretical aspect in design is very essential for design features of cofferdam. So here all the forces acting on the cofferdam are shown. So first it is self weight F1, then F2 is the water weight, so there is a weight of water. Third is F2 dash, that is the thrust due to water. Next is uplift pressure, that is F3. So this is uplift pressure, that is equal to F1 plus F2. F4, that is erosion of cofferdam surface, so that is considered erosion. Then F5 is the impact force due to floating substance, if some floating substance are there that are going to affect it. So these are the forces to be considered for the design of cofferdam. Now what are the factors that will govern the economic height of cofferdam? So first thing, economic height means the maximum height of cofferdam for which its cost is minimum. ऐसी height की जहाँ पे cost minimum हो. So it depends upon the flood level. So if the cost of increasing height of cofferdam, if it is greater than damage caused by the flood का जो डैमेज हो रहा है उससे आपका कॉस्ट बढ़ाने का ज़्यादा हो रहा है, इट इज़ चीपर टू एज्यूम द रिस्क ऑफ लॉस ड्यू टू फ्लड डैमेज देन टू बिल्ड अ कॉफर. तो उस केस में आपको कॉफर डैम ज़्यादा हाइट का बनाने की ज़रूरत नहीं है. एंड वी कैन हैव डैम विद द लिमिटेड हाइट. But if cofferdam is constructed to exclude the normal flood water and provision is to be made to bear the damage caused by the higher flood level, because otherwise it will be very costly. But if in case cost of increasing the height of cofferdam is less than the cost of the damage caused by the higher flood, अगर flood बहुत ज़्यादा आ रहा है और आपका cost तो कम ही है, so in that case you can increase the height of cofferdam. Next is depth of water. For the low depth water, generally the earthen dam is used, and for the higher depth of water, sheet pile cofferdam is used. For the current and natural flowing water, for the high current, generally sheet pile cofferdams are used that are higher seepage control capacity, and for the low current, earthen or other cofferdam can be utilized. And this height and width criteria we have already discussed in wood sheeting cofferdam. Now one phenomena which is called as piping in single wall cofferdam. So as water start entering the cofferdam, the soil is removed by percolating water which replace the further soil. एक बार अगर पानी आना स्टार्ट हो गया तो फर्दर सॉइल को रिमूव करना स्टार्ट करेगा, and that will be a dangerous condition. So when the hydraulic gradient at the exit का जो hydraulic gradient है, it exceeds the critical gradient, it replaces the soil further. तो ज़्यादा से ज़्यादा soil remove होता जाएगा, and this process continues and sort of pipe is formed. तो एक pipe का form ले लेगा and this allows the larger amount of water to rush through the channel and which may be responsible for the failure of cofferdam. तो बहुत ज़्यादा अगर soil replace हो रहा है and pipe का जैसा channel बन रहा है then it may result in failure of cofferdam. So as per our Darcy's law, we are knowing that V is equal to Ki, and I is what? That is H upon L. So V is velocity of flow, K is Darcy's coefficient of permeability, I is hydraulic gradient, H by L. So H is hydraulic head and L is seepage length. So now what we want to do? We want to reduce this piping or we want to eliminate it. So piping can be eliminated by reducing the exit gradient. क्योंकि हमको exit gradient करना है कम. So if you want to do it or we want to minimize it, there are two options because H and L, these are the two variables. So by increasing the length of seepage का जो length है उसको बढ़ाओ, तो ये आपका L that is denominator, अगर आप उसको अगर ज़्यादा कर रहे हैं तो आपका हाइड्रोलिक ग्रेडियंट हो जाएगा कम. So by increasing the length of seepage, so how can you increase the length of seepage? By inserting the sheet piles at more depth, so that will increase your L and that will reduce your hydraulic gradient. And second option, by reducing the head of water which is responsible for causing seepage, so by pumping. So if you are doing pumping, then your hydraulic head of water that you are reducing and that will result in reduction in hydraulic gradient. So this way you can avoid piping in case of cofferdam if it is coming. So thank you very much. I hope that whatever contents that are given in your syllabus, everything I have covered and that will be very useful to you in the examination. So thank you very much. Thank you.